How much time did you spend studying vectors in one dimension? I spent 30 minutes south. I spent an hour north and 15 minutes to the west. It doesn't really make sense. That's because time is a scalar and not a vector. It only has magnitude. So what are scalars? We're saying that scalars are physical quantities which have only a number value or a size or the so-called magnitude, right? A scalar tells you how much of something there is. For example, we have time, like I've talked about, and a mass. If you have a mass of 60 kgs, you just have a mass of 60 kg. There's no 60 kg to the right or 60 kg to the left, right? Because time, mass, electric charge, and so on, they are scalars. They only have a magnitude and no direction. But then vectors, on the other hand, are physical quantities that have both a magnitude and a direction, right? A vector tells you how much of something there is and in which direction it is in. For example, we have force, weight, and velocity, right? Those are all vectors because they tell you the magnitude and the direction. When you're applying a force, you're applying a force in which direction? Now the question that comes is, how do we represent these vectors that we talk about that have magnitude and direction, right? We can graphically do so, and that's what we're going to talk about next. So if we just scroll down here, we can see that we have graphical representation of vectors. So when you want to present a vector graphically, you have to put a tail, the body, which denotes the magnitude, and the head. The head shows you the direction of the vector, and then the length of the vector is mapped to its magnitude. So for instance, if you represent a force of 100 newtons, then a vector for that force should be greater than a vector representation of a force of 10 newtons. Right? It should be longer than that of 10 newtons. That's how it works. When you beginning your studies in vectors, usually they're very strict with the length. So they will give you a scale to use. But once you get advanced, we really don't care, right? As long as we can see that the vector of a 10 newtons force is less than that of a 100 newton force, we are happy, even if you don't map them accurately. So the first question here is saying that let's draw the following vector quantity. V is equals to 6 meters per second north, right? So we're talking about velocity here. So let me go ahead and sketch that vector and show you how it is supposed to look. As you can see, we have 6, which is the magnitude, and we have north, which is the direction, because in vectors, we always have a magnitude and a direction. So we're going to have something of this manner, right? And then this is our 6 meters per second vector pointing north, right? And that's exactly how you're supposed to do it. The second question, draw the following vector quantity. V is equal to 16 meters per second east, right? On the first question, we had 6 meters, right? And then on the second question, we have 16. So we're expecting the length of this vector to be greater than that in the first example, right? Because it has a greater magnitude, right? So if we start here, then we just go in to the east, right? Your line must be straight, must not look like mine. And then we know that this is 16 meters per second east, right? And then the third question, draw the following vector quantity. A force of 3 newtons at an angle of 30 degrees, right? So vectors, they're not always straight. It can come in an angle, right? And you should be able to sketch it, right? So let's just go ahead and do that. So if this is our tail, and then we can have an arrow like this, and then there goes our head, and then let's indicate our angle here. We have an angle of 30 degrees, right? Usually, if they just give you an angle, then you can always assume that that is an angle of inclination. But then sometimes they're specific, maybe 30 degrees from the north when you count in clockwise or when you count in anti-clockwise, right? Depending on what the question says. But then usually if it doesn't say anything, then you just take that angle as an angle of inclination, right, from mathematics. The question that I want to now ask is, what if we have 3, 4, 5 vectors acting at once? Let's talk about addition and subtraction of vectors. So when vectors are added or subtracted, we need to take into account both their magnitudes and directions, right? When vectors are added or subtracted, we need to take into account both their magnitudes and direction. This is so important, and I'm going to show you why. So let's look at this first example here, example 1. So example 1 is saying that a tennis ball is rolled towards a wall which is 10 meters away from the ball, right? If after striking the wall, the ball rolls a further 2.5 meters along the ground away from the wall, let's calculate algebraically the ball's resultant displacement, right? So let's just have a sketch to conceptualize what you're talking about. So let's say this is our starting point, right? And then we have a ball that is rolling towards a wall which is 10 meters away. So let's have a vector. After having this vector, let's say that this is 2, 4, 6, 2, 4, 6, 8, 10, right? So we have rolled 10 meters away from the ball towards the wall, right? And then after striking the wall, the ball is obviously going to go back where it's coming from, right? It is said that it rolls a further 2.5 meters along the ground away from the wall. So let's denote that with a vector 2. So starting where we ended, let's go backwards because that is where the ball is rolling. So if we do that, then we're going to be somewhere there, right? So this vector's 10 meters towards the wall, and then here we have 2.5 meters away, from the wall. So now we can see clearly that we have two vectors that are pointing in on opposite directions. We need to decide which direction we're taking is positive and which direction we're taking as negative. So let's take the direction towards the wall as positive and the direction away from the wall as negative, right? We're just respecting the Cartesian plane, right? You can do it the other way around, but then for this video, I'm just going to take the direction to the right as positive and the direction to the left as negative. So now this first vector will have a magnitude of 10, right? Because we're taking that direction as positive. And then the vector that is pointing away from the wall, we're going to put a negative value to its magnitude to show that it's going to the opposite direction. So we're going to have minus 2.5, right? So now let's calculate the resultant. The resultant will be, so we have, let's put x for displacement, right? So the resultant will be x1 plus x2, right? So this will be equals to, so x1 we can put either, right? So let's put the first one, which is 10, right? 10 meters away from the ball and towards the wall. And then the second one we're gonna put plus, but we put in a negative value to the magnitude of that vector, right? So plus minus 2.5, which is going to be equals to 7.5. So this is how we do it algebraically. Another way of thinking about it is you took 10 steps to the right, and then after taking 10 steps to the right, you take 2.5 steps backwards. So how many steps did you take to the right overall? That is just 10 minus 2.5, which is 7.5. Right? So that's another way of thinking about vectors and so on. But let's do another question so that we can cement this idea, right? So a man applies a force of 5 newtons on a crate. The crate pushes back on the man with a force of 2 newtons. So let's calculate algebraically the resultant force that the crate experiences, right? A man pushes on a crate with a force of 5 newtons, right? So let's say this is 1, 2, 3, 4, 5, right? And then the crate is pushing back on the man with a force of 2 newtons. So we start in where we ended and we go in back, right? Clearly from the graphical representation, we can see that the crate is going to experience a resultant force of 3 newtons. But then the question says, let's do it algebraically, right? So let's go ahead and do that. So if we do that, we're going to have Fr being the resultant force being equals to F1 plus F2, right? Now we have to decide on the direction. So let's take the direction the man is pushing towards as positive, and the direction the box is pushing back on the man as negative, right? So F1 we can write 5 newtons, and then for the force the crate is pushing back on the man with, we can substitute it with a negative value to show that it is going to the opposite direction. So if we add that 2, we're going to get 3 newtons. So the crate is going to experience a force of 3 newtons to the direction that the man is pushing on, right? So we have to put direction here. So if, for instance, the man is pushing to the east, then we would write 3 newtons to the east, right? We need not only a magnitude, but a magnitude and a direction, right? So this is how you would solve a problem like this. But then these things, they don't only occur along the x-axis, they also occur along the y-axis. But then the physics is still the same. We solve the problem the same way we're solving it here, right? Let's just do one more problem before we move forward. I just want to demonstrate something, right? So let's say we have a vector of 4 newtons, and then we have another force of 5 newtons, right? Let's just add another force. So let's say we have another force here and then another force here, right? Let's say this force here is 2 newtons, and this force here is 0.5 newtons. So how would we solve a problem like this? Step 1, we have to decide which direction we take in as positive, right? So let's take up as positive. It only makes sense to take up as positive. I don't know why you would want to take up as negative, right? So if we do that, we're going to get a resultant force, which is F1 plus F2 plus F3 plus F4, right? Just the number of forces that we have, right? So what is F1? Let's take the 4 newtons force as F1. So because it's pointing up and we're taking up as positive, we're just going to put 4, and then plus F2, which is 0.5, right? It's pointing up, we substitute it as it is. And then for F3, the 2 newtons force, we're going to put a minus sign because it's pointing down and we're taking up as positive. And the fourth force, 5 newtons, we're putting it with a negative sign because it's pointing opposite to the direction we're taking as positive, right? So now we have 4.5 minus 7. Right, that's what we're going to end up with. So what is 4.5 minus 7? That is minus 2.5, right? So you can see that we have a minus sign, right? We cannot leave our answer with a minus sign, right? The minus sign is only giving us the direction. So we have to come here and say 2.5 newtons downwards, right? That's all we have to do. We cannot leave our answer with a minus sign, right? And a minus sign is only a direction. We have to fix that and write it in words. So this is how we would solve a problem like this, right? But then, I'm sure you get this. But what happens if you have a force pointing up and then you have another force pointing horizontally, right? How will you solve this kind of problem? That's where now we have to talk about vectors in 2 dimensions. Right, so let's go ahead and see what we have. So vectors in 2 dimensions, well, there's just a slight difference, right? We need to find the resultant of the horizontal vector. So vectors are in the x, right? And then after we find the resultant of those vectors, we need to find the resultant of the vertical vectors. And then if we have those two, we just use theorem of Pythagoras to find our resultant vector, because it's going to be somewhere in the middle, right? So let's say, for instance, we have 4 here and here we have 3, and we want to find the resultant vector. We're just going to use theorem of Pythagoras. So FR squared, if we're talking about forces, will be Fx squared plus Fy squared. So this will be 3 squared plus 4 squared, right? So you solve the problem like this, right? And then if we take it a step forward, I can give you a vector at an angle, right? At an angle theta, and say, give me the vertical component, give me the horizontal component. If you think that is complicated, it's not. Let's solve a few problems so that I can show you how we solve this kind of vectors, right? So let's have the first case, which is gonna be pretty much straightforward. So let me just remove this and let's get to it. So if I remove this, let's say we have something of this manner. So let's say we have a vector pointing up, and then we have another vector pointing horizontally. That's not it all. Let's put another vector here, and then let's put another vector here, right? So let's say that this vector here, it has a magnitude of 5 newtons. If we're talking about forces, here we have 2 newtons, here we have 6 newtons, and here we have 2 newtons, right? So step number 1, like we've already talked about, find the resultant along the vertical, find the resultant along the horizontal, and use theorem of Pythagoras, right? So let me show you what I'm talking about. So let's see Fx, right? So we're finding the resultant along the horizontal. So the 6 Newton force is pointing to the right, and Cartesian plane wise, that is positive. So let's just go ahead with that. So this is going to be 6, and then plus the 2 Newton force with a negative sign because it's pointing to the negative direction. So we're going to have minus 2, right? So the resultant horizontally is going to be equals to 4 newtons. Now let's find the resultant vertically, right? So we're going to have Fy being equals to 5. It's positive because it's pointing up, and then the 2 Newton is positive because it's also pointing up. So the resultant along the y, it's 7 Newton. So if we want to find the overall resultant force, we're going to have Fr squared being equals to Fx squared plus Fy squared. So Fr squared will be equals to the x, the resultant along the x, which is 4 newtons, right? So we're going to have 4 squared plus the resultant along the y, which is 7 newtons, right? So we squared that. At this step, I don't want you to do anything else. Let's take square roots on both sides immediately. So we're going to take a square root on this side, and then we're going to take a square root on this side, right? So Fr is going to be equal to. So at this step, I just want you to put everything in the calculator. If you do that, you're going to get 8.06 newtons, right? So your resultant force is 8.06 newtons, right? It's going to be somewhere here. It's going to be somewhere here, right? Let me just do it in black so that we can show that it's different from the others. So it's going to be somewhere here, right? So here we have a force of 8.06 newtons, right, at some angle here. Now the question is, What is that angle? Can we find that angle, please? Because a force is a vector. We need a magnitude and a direction. To find that angle, it's pretty much straightforward. You can use any trig ratio of your choice. But then, let me just use tan, and then you will realize why I'm using tan as we go forward, right? So if I want that angle, I can say that tan of theta is equals to the opposite divided by the adjacent, right? So theta is going to be tan inverse of the opposite is the resultant along the vertical axis, right? So it is 7 newtons. So we can go ahead and put that, right? And then the adjacent is the x, right? It is adjacent our angle of interest. So that will be 4, right? And then now it's just a matter of putting that in our calculator. So if we do that, we're gonna have 7 divided by 4, and then I'm getting an angle of 60 degrees, right? Which makes sense because the y value is greater than the x value, right? So the angle must be greater than 45, right? Think about it. It makes sense. Just take some time and think about that. If the y value is greater than the x value, then the angle must be greater than 45, right? In the first quadrant, that is. Okay, let's move forward and do the next problem. I hope this makes sense, right? So what can we do now? So if you want to take a screenshot of this, please take a screenshot of this, because I'm going to erase it so that we can solve the next problem. So yeah, take a screenshot. Yeah, I'm assuming that you did that. So yeah, we have to move to better things. So let me get rid of that, and we can carry on solving our problems, right? So what can we solve now? Let's say we have something of this manner. We have that is still there. Let me just erase that too. Yeah, let's say we have a force along the horizontal pointing in that direction, and then a force along the vertical pointing down, right? Here, I just want us to think about how we can deal with the angle, right? So let's see that this is 6 newtons, and then this is 3 newtons, and solve our problem. We want the resultant force. So we're going to find the resultant along the vertical and the resultant along the horizontal. And we already have that, right? So you just plug and play in this point. So we have F resultant squared being equals to the resultant along the x squared plus the resultant along the y squared, right? So FR will be equals to, so we're going to have the resultant along the x, so that is going to be minus 3 squared, right? Because we take up and to the right as positive, plus minus 6 squared, right? But you might be thinking, why are we even putting the minus signs here? Because it doesn't really affect our answer, right? At this step, it doesn't affect our answer, but then you will see that soon it's going to affect our answer. So now we have a resultant of 6.71 newtons, right? So obviously our resultant is going to be somewhere here, right? And then it is 6.71 newtons, right? And then now we have to find an angle. Unless the equation is very strict with the angle it wants you to find, then this is the angle I want us to find, right? This angle here is the angle I want us to find if the equation is not strict about which angle. But then it doesn't really matter. If the question says, let's find this angle instead, then we're just going to minus that angle from 90 degrees because we know that this is 90, right? And then if the question is saying, let's find this entire angle, then we still just going to find this angle and then plus 180 degrees because from here to here, it's 180 degrees, right? So whatever the question is saying, we can just find this angle only and find a way to move around that. So how would you find that angle? Let me show you something, right? So the x is still our adjacent, right? And then the y is still our opposite, right? And then the resultant will always be our hypotenuse. It never changes. So we can just use tan all over again. So if we do that, we're gonna have tan. So we already know the formula, so let's not copy the formula again. Let's just say that theta is equals to tan inverse of opposite divided by adjacent. So opposite is our y, so that is 6 divided by 3. I just want to apologize real quick. 6 and 3 should have minus signs, but then the answer is still going to be the same. So we're gonna get 63.43 degrees, right? So that's how we can find that angle, right? And then now on angles, let's just do the last question before we move to questions where we have where we given vectors at angles and we're supposed to find the components, right? So let's just do one more question. So what if we have something of this manner? Yeah, think it can fit in here. So I'm just gonna put it here. So what if we have starting here at our tail, and then we have one vector pointing up and then another vector pointing in this direction. If we have something like that, our resultant is gonna be somewhere here. So how are we gonna find the angle when the situation is like that? That's exactly where I want us to go. So let's say that this is 10 newtons and this is 8 newtons, right? So step number 1, we're going to find the resultant, right? So if we do that, we're gonna have f resultant squared being equals to fx squared plus fy squared, right? So fr being our resultant will be equals to fx, so we have minus 8, right? And then plus 10 squared, and then we take square root on both sides. So for the sake of space, I'm just going to take this to the power 1 divided by 2 because it is basically the same as taking a square root, right? So when I punch that in my calculator, I'm getting 12.81, right? So we know that this force has a magnitude of 12.81, but force is a vector. We need magnitude and direction. Let's go ahead and find our angle, right? So which angle is it that we're looking for? Is it this angle here or is it this angle, right? Is this angle here that we're looking for? Why are we choosing that angle? We're choosing that angle so that y is still our opposite and x is still our adjacent. So let's go ahead so that I can show you something. So if we do that, we're gonna have theta being equals to tan arc of opposite divided by adjacent. So opposite is 10 and then adjacent is minus 8, right? So if you punch that in your calculator, you're gonna get minus 51.34 degrees, right? So now we have minus. How do we solve this? You just take it as a positive. That's what you do. You take it as a positive and you move on with your life, right? It works. Just trust me. You take it as a positive and you move, right? So this angle here will be 51.34 degrees because I'm saying so. You just take it as a positive and you move. I hope that is clear. So let's move on to the following equation, right? So now I want us to have vectors that are pointing in directions, and then the question is still the same. Let's find the resultant. In that case, we would have to resolve the vectors. That's where I want us to go. So just to introduce you to the formulas we use when we're resolving the vectors. So let's say that we have a vector of 5 newtons, and then this angle here is 36 degrees. And then the question says, find the vertical component, find the horizontal component. right? So let's start with the vertical component, right? Vertical component being our y. So the y, right? So let's say our resultant. Let's use force as an example again. So let's say we want fy, right? Our vertical component. We're gonna say fr, right? The resultant force itself multiplied by sine of 30 degrees, right? Where is this coming from? It's easy to prove. Think about it. Think about sine of this angle, what is going to give you, and solve for fy, right? Think about it. Yeah, let me know in the comments if you get it. Yeah, but this is what you use if you want to find the vertical component. And then if you want to find the horizontal component, it's going to be the opposite. Instead of sine, you're going to use cos. So we're going to have fx being equals to fr multiplied by cos of let me not put 30 here because I was just making reference to that angle. We just use theta, whatever the angle is. Yeah, this angle here is actually not 30 but 36 degrees, but we just use theta, whatever the angle is. But then it's going to become clear as but it's going to become clear when we solve the problem, right? So that's the formula we use there. Let's just do it for this question so that we can see what is going on, and then we can move on to better things. So here, if we want to find fy, so that is going to be 5 multiplied by sine of 36 degrees. So let me put that in my calculator real quick. So that is sine of 36 degrees, and we get in 2.9389 degrees, right? Now let's find the horizontal component fx. So fx will be equals to 5 multiplied by cos of 36 degrees, right? So let me just put that in my calculator real quick and see what I get. So instead of sine, we have cos, and I'm getting 4.05 newtons. I don't know why I'm putting degrees. Newtons, right? So that's what we have. So when we have these two numbers, we can then use theorem of Pythagoras and see if we're gonna get 5 newtons. Okay, what am I saying? I'm saying that we can say that fr squared. So let's not even put a square because now we already know the formula we're supposed to use, right? So we're gonna have 2.9. So let's just say 2.94 squared plus 4.05 squared, and then we take everything to the power a half, which is just another means of squaring. So 2.94 squared plus 4.05 squared. When I do that, I'm getting 5.0046 newtons, right? Which is a result of the rounding off, right? I'm getting 5.00 something because I rounded off, right? If I just wrote everything as it was, I was just going to get exactly 5, right? 5.004 is still exactly 5, but you get what I mean. So this is how we solve this kind of problems. But then now, let's take it a step forward. What if we don't only have one force at an angle? We have 2, and then we want a resultant of that 2. How would you solve that? Let's do that. And then after we do that, we're going to go to the last question, which is a past exam question. Actually, let me give you a sneak peek before we solve this one. So this is the question we're supposed to be able to solve at the end of the day. We should be able to do this question, but we're going to come back to it. Let's just do one more problem before we solve that one, right? So screenshot this if you need it, because I'm about to erase it. Assuming that you did that, let me get rid of this, and then we move to better things. So let me, gone, right? And then let's have a sketch so that we can so another force acting at an angle. And then now what we do in different is we also put in another force acting at an angle, right? So let's say that this is 7 newtons and then this is 6 newtons. We can put an angle of 30 degrees here, and then here let's put an angle that is a bit low, 20 degrees, right? So let's go ahead and find the resultant vector, the resultant force of these two forces acting at a point. So back to the basics. We find the resultant along the x, we find the resultant along the y, and then we jump to theorem of Pythagoras and then use tan to find the angle. So let me show you what's going to happen here. So Fx, right, the resultant along the x. So let's start with the 7 Newton force, right? So we're supposed to find the x component of the 7 Newton force. So we're going to say 7 multiplied by x component, we use cos. So that is cos of 30 degrees. Now we need to add the horizontal component of the 6 Newton force. But then the 6 Newton force, the horizontal component is going to be pointing to the negative direction. So we must put in a minus, right? So let's say plus and then minus 6 multiplied by cos of 20 degrees, right? So that's how we would find the resultant vertical forces acting at that point. So 7 cos of 30 plus minus 6 multiplied by cos of 20, and then I'm getting 0.424 newtons, right? Which is a positive number. So yeah, we're just gonna write it like that. So let's say positive and then let's say east, right? Yeah, because we have to indicate the direction. And then now let's move to the vertical components. So we're gonna say Fy is equals to, so all the vertical components of these two forces are pointing up, right? So we're just going to put them as they are, right? We're not going to put a negative sign. So we're gonna say 7 vertical component sine of 30 degrees plus 6 multiplied by sine of 20 degrees, right? So if we compute that, 7 multiplied by sine of 30 plus 6 multiplied by sine of 20, right? And then the answer here is 5.55 newtons, right? So if we were to sketch our resultant would be oh no, we actually don't have our resultant. We just have the x component and the y component. Let's go ahead and find our resultant. I'm getting ahead of myself. So F resultant is going to be equals to, so 0.424 we square that plus 5.55 we square that, and then we take everything to the power a half as a way of taking square roots on both sides. So let me put that in my calculator real quick so that I can see what I have. So we have 5.56. So 5.5, let's just round it off, 7 newtons. So if this is east, then this is the north, and then this here is at an angle. So we are yet to find that angle. So to find the angle there, we're just going to do what we've been doing all the time. We're just going to use tan. The x and the y, they're all positive, so it will be easy to navigate. I'm going to leave it to you guys. And then now, the last question, the exam question, what we're excited about. We have 3 forces P, Q, and R of magnitudes 500, 200, and 300 newtons, respectively, acting on a point O in the directions shown in the diagram. The forces are not drawn to scale, but we don't care because we'll solve algebraically, right? We're not going to be doing any measurements whatsoever, right? So the question here is to find the resultant force acting at that point, right? So we're going to still stick to the basics. We're going to find the resultant along the x, the resultant along the y, and then find the resultant itself. So let's go ahead and find the resultant along the x. So if we do that, we're gonna have fx being equals to, so let's start with point P. So point P has a force of 500 newtons, right? And then multiply by, if it is the x component, we use cos, right? So cos of, nope, not 10 degrees, right? Because we always count our angle from the x-axis, right? We use the angle of inclination. You can use 10 degrees, but then you would have to change something. I don't want us to get to that. It will just lead to confusion. So to find that angle, we just say 90 degrees minus 10, which is going to be 80 degrees. So you have to be careful. You just don't see an angle and use it. Think about it first, right? Yeah, cos of 80 degrees. Let me know if you get it in the comments, right? So cos of 80 degrees. And then plus, let's move to Q. So that is 200 newtons multiplied by, that one is pretty much straightforward, cos of 30 degrees, right? And then now we have R, which the x component is in the negatives, right? It's in the negatives. So we're going to put a minus sign there so that we can account for that, right? So we're going to have minus 300 multiplied by cos of 60 degrees, right? So if I put this in my calculator, I'm going to find my horizontal component. So let me just punch that in and see what I get. So cos of 30 minus 300 multiplied by cos of 60. So let me just, it seems like all is well. So we have 110.0292 newtons to the east, right? Yes. So now let's move to the y component, right? The resultant along the y. So we just so the 500 Newton force, the y component is pointing up, right? So we're gonna have 500 multiplied by sine of 80 degrees plus the 200 Newton force, the y component is also pointing up, right? So we're going to have 200 multiplied by sine of 30 degrees. And then R, the y component is pointing up. So again, we have a negative sign. 300 multiplied by sine of 60, right? So let me just put that in. So I'm just replacing cos with sine here. The answer I'm getting here is 332.59663. What am I writing? 63 newtons up, right? So pointing north. So now I have the vertical and the horizontal. I can find the resultant. So the resultant is going to be equals to we already know that we're going to take everything to the power 2 as a means of squaring. So we're going to have 110.0292 squared plus 332.5963, right? And then we square that and then take everything to the power a half as a means of taking square roots on both sides, right? So we should get 350.33 newtons, right? So we have the value of the resultant. We can go ahead and find the angle, right? So the angle, we're gonna use theta being equals to tan inverse of the opposite divided by the adjacent. So the opposite, we always use the y value, right? So we're gonna have 332.6, and then adjacent, the x value 110.029, right? And this will be 71.7 degrees basically. So we have the magnitude and we have the direction.